Hello everyone, so we will be looking at properties of geometry. So we will start off with triangles. So in this first video we will be looking at all possible properties of triangles. So let's start. So first, if you have a triangle, so the first property that we all know is sum of the angles is 180. The second property is exterior angle A, means at A if you draw the exterior angle, so we will call it exterior angle A, will be equal to 180 minus A, but 180 minus A is the other two angles, so it is angle B plus angle C. All the other exteriors, so exterior of C will be A plus B and exterior of B will be A plus C. Number 3, the larger angle is opposite to the longer side, the smaller angle is opposite to the shorter side. So that means here if I say that angle A is bigger than angle B and greater than angle C, if that is the case, that would imply that opposite to A is BC, opposite to B is AC, opposite to C is AB. Number 4, properties of the sides. Sum of any two sides is greater than the third side and the third side is greater than the difference between the other two sides. So any side is less than sum of other two sides is greater than difference between other two sides. Okay, number 5, Pythagoras theorem. Pythagoras theorem basically an extension of this, if this angle at B is less than 90 degrees, so this B is now less than 90, it is an acute angle. So then the property would be B squared is less than A squared plus C squared, okay, and if the angle now becomes greater than 90 degree, this angle, then B will become greater than A squared plus C squared, okay. A more precise formula if you want in terms of trigonometric ratios, if this angle is theta, the relationship is B squared is A squared plus C squared minus 2AC cos of theta, okay. If it is a right angle triangle, cos of 90 is 0, so then it becomes Pythagoras theorem, okay. Next, number 6, it's about area. This is height and this is base. So base times height. Different way of looking at this is A, B, C, okay. This is small c, this is small a. Now if this angle is theta, in trigonometry again, if you look at this, H is basically C times sine of theta. So B times C times sine of theta. So it is multiplied with sine of between them. So that's another find out if you know the angle and you know the sine of that angle. The another formula for finding out area is, if I know the three sides, let's say small ABC, we define S to be the semi-perimeter, means sum of the three sides by 2, then the area is root over S times A times S minus B times S minus C. So this can be used for any triangle. So for any triangle, if you want to find the area, use this and then you can proceed further. So if I want to find what is this height, then I'll find the area, then equate it to half times H times A and find out what the height is. So this is about area. There are other things in area also, we will come to that later. Next, an extension of this rule is, if two triangles lie between the same parallel lines, that means the two triangles will have the same height. Okay, if I drop this perpendicular, this height will act as height for both the triangles. So if I call this as x and if I call this as y and the height is same, so area ratio will simply be x is to y. Okay, half times h times x to half times h times y, h will cancel out, we will get x is to y. Okay, area ratio is x is to y, so that means equal to base ratio if height is constant. Okay, that's the thing that we get from this. Now to consider some special triangles. Isosceles triangles are, two sides are equal and hence the angles opposite to them are equal. Another property which is very important is, if you were to drop a perpendicular from the unequal angle to the unequal side, it will bisect that unequal side and the unequal angle. So perpendicular from the unequal vertex to the unequal side, this has to be the case. Then we can take this to be the height and this to be our base and use half to find the area of this triangle as well. If I know this side, we can calculate the height using Pythagoras theorem. Okay, so this is basically how we tackle isosceles triangles. A special isosceles triangle is the right angled isosceles triangle, which is 45, 45, 90. The side ratios for this are L and from Pythagoras theorem L root 2. So remember, 1 is to root 2. Root 2 is the line length opposite to the right angle, the hypotenuse. Next comes equilateral triangles. So equilateral triangles, all three sides are equal. As a result, all three angles are also equal. So they are all 60. And here again, if I drop the perpendicular, it will bisect the base and this will become 30, 30. So if I have the sides as L, then this will be L over 2 and my height becomes square root of L squared minus L over 2 whole square, which will come out to be square. So it will be L root over 3 over 2 and area would be half base, which is L times L root 3 by 2. So L square root 3 by 4. So we have area as root 3 over 4 times square of the side and the height to be root 3 by 2 times the side. That's number one. The other thing that we get is this special triangle, the 30, 60, 90 triangle. If you take a look at this, and this is very useful as well. Look, we have just now reduced the sides. So this is L over 2, this is L and this is root 3 L by 2. Okay, root 3 L by 2. So here, point to note, if opposite to the 90 degree, the hypotenuse, okay, is length L, from the hypotenuse to the side opposite to 30 degree, you divide by 2. Okay, from here to the side opposite to 60 degree, you multiply root 3. So the ratio of the sides, you can remember this, is very helpful, is 1 half and then root 3 by 2, or if I multiply this with 2, so it's 2 is to 1 is to root 3. Root 3 is opposite 60. That is the hypotenuse. So we have the 30, 60, 90 property and the equilateral triangle. So essentially these are the 5 more important properties of triangles that we have. Thanks for watching.